In this video, we're going to introduce yet another form of a linear equation. This time, it's point gradient form. Okay, so we've looked at gradient intercept form. This is y equals mx plus c. We've looked at general form, which is ax plus by plus c equals 0. But let's say, for example, you had a line where the gradient was known and you sort of passed through a point other than the y-intercept. Then there's another form that does make that process of finding the equation of the line a lot easier. Just consider this example. Let's say we had a line, okay, and the line passes through 2 points, or passes through infinite points, of course, but these 2 particular points that it passes through. Passes through the point A, which is x1, y1. So that's like a known, think of it as a known point, okay, it's given. And then there's this point B, which passes through the point x comma y. That can be anything. Think of it as a variable point. Sort of, it's any point that can move along the line. So think of A as some fixed point. Okay, so set can't move. Think of point B as a moving or a floating point, right? Or just as a point that's variable. So it doesn't really matter where point B is. It can be anywhere on the line. What would the gradient of that line be? Okay, we know that m is equal to really y2 minus y1 over x2 minus x1. We know that form, we've seen that form as a 2-point formula for gradient. But our x2, y2, sorry, belongs to point B. And it's just x comma y. So m is equal to, now our y2 is just y. Our y1 is just y1 over x2 minus x1, so that's our run. Our x2 is just x minus this fixed point x1. Now, if we multiply both sides then by x minus x1, what do we get? We get m outside of x minus x1 is equal to y minus y1. Now, if we switch the left-hand side and the right-hand side around, and I'll do this in a different color, so hence, okay, we have y minus y1 is equal to m outside of x minus x1. So the y minus y1 is actually the rise in this example, and x minus x1 is the run. And so just by simple manipulation, we end up with another formula here called the point gradient formula, or the point gradient form of the linear equation. Okay, so this is it. Okay, so what it's all about. So this is really, think of it as a bit of a shortcut, right? Sort of something that can really help you to find the equation of a line where we don't have the y-intercept, but passes through another point and we have the gradient of that line. So look at some examples. Find the equation of the line with gradient negative 1 on 3, 1/3, and passing through the point 2, 5. Now, you could do this by first principles. You could use the gradient intercept form, y equals mx plus c. You have the m already. You just got to find the plus c. You can substitute in 2, 5 and find the plus c. And then you've got the equation of the line. Now, that can take a little bit longer than using the point gradient form. Both equally valid methods. I'm not saying that one method is necessarily any better than the other, but this method will certainly save you some time rather than sort of going back to using y equals mx plus c all the time and then having to solve for c. So this one's very straightforward. Y minus y1. Okay, so this is our y1 here, so and this is our x1. Okay, y minus y1 is equal to the gradient, negative 1 on 3, outside of x minus x1, which is 2. Now, that's the point gradient form. We still need to convert it into one of the standard forms, that either gradient intercept form or general form. So if you wanted gradient intercept form, you move the negative 5 over by plussing 5 or adding 5 to the other side, expanding the brackets, and we're fine. Or we could use general form. In fact, if you're not asked to find the equation of the line in any particular form, you can use whichever form you like. You can either pick gradient intercept form or general form, whichever is more convenient. Okay? If you're asked specifically for a particular form, then obviously you must give the equation in that form. I'm going to use general form only because it's, you can get rid of the fraction here and sort of make it looks nice and neat. Multiply everything by 3. Okay, so 3 times y is 3y. 3 times negative 5 is negative 15, is equal to negative x minus 2. Okay, so I just multiplied everything by 3. Now we could just expand the brackets, so 3y minus 15 is equal to negative x plus 2. Okay, so it's just basic algebra now, it's just algebra. Okay, and moving everything over to one side, the negative x becomes positive, so x plus 3y. And you've got negative 15, now take away another 2, so subtracting 2 from both sides, we have negative 17 is equal to 0. And that would be the equation of the line with gradient negative 1/3 passing through 2, 5. Let's have a look at another example. Okay, and I think we've seen an example similar to this in a previous video, but where I used the gradient intercept form, in fact, to find the equation of a line. This time around, we can use the point gradient formula. It'll save us a little bit of time. Find the equation of a line passing through the points 3, 4 and negative 2, negative 1. Now, if you like, you don't have to do this, but just to help with visualization, you can draw just a quick sketch, if you like, of a coordinate plane, x, y in our origin. Now, 3, 4 is somewhere here. Okay, I might just label these points, it makes it a bit easier. Okay, so that's our point A, 3, 4. Okay, and our point B is actually back here somewhere, probably here, and that's negative 2, negative 1. So we've got a quadrant 1, quadrant 3 points. So A is in quadrant 1, B is in quadrant 3. Okay, and definitely A is much higher than point B. So if we sort of sketch a line there, we can see that the gradient's definitely going to be a positive gradient. Not quite sure about the y-intercept, doesn't really matter. We can use the point gradient formula and that'll take care of that for us. Right, first thing we need to do is find the gradient. Before we can use, the point gradient formula, y minus y1 equals m outside of x minus x1. Let's find m. Okay, is equal to y2 minus y1 over x2 minus x1. Okay, and that's sort of having 2 points that defines the location of the line and also defines its gradient as well. So this is our x2, y2. This is our x1, y1. Okay, so y2 minus y1. Okay, so that's going to be 4 minus negative 1. Okay, so there we go. Make sure we get that right. 4 minus minus 1. Obviously, it's going to be a positive over x2 minus x1. So it's going to be 3 minus, let's have a look here, 3 minus minus 2. Yep. And just quickly cleaning that up, that gives us 5 over 5. Okay, so it gives us a gradient of 1. Okay, it's very convenient actually. So passing through now a particular point. So we're given 2 points here to pick from, and I'd like to pick a point there that sort of tends to use positive values, just a lot easier. So using the point gradient formula, okay, y minus y1 is equal to m outside of x minus x1. Okay, so y, now I'm going to use point A here and substitute that point there into the point gradient formula. And y1 is 4. Now m is 1. Okay, that just happens to be very convenient there. X minus x1. Okay, and now x1 is 3. Okay, so that's y minus 4 is equal to x minus 3. Moving the minus 4 over the other side becomes, we'll sort of move that over by adding 4. So y is equal to x, now minus 3 plus 4 plus 1. So in this particular example, it was just more convenient to leave it in gradient intercept form. So our y-intercept there is in fact 1. And that's it.